The last bit of 5.5 is about the intermediate value theorem. The intermediate value theorem states that if a is less than b, these are x values, and f of a and f of b, which are y values, have opposite signs, then f of x, which is the function, has a real root, which is also called an x-intercept or a zero, somewhere between the x values of a and b. So here's like my x-axis, and I have two x values on it, a and b. It tells me that a is less than b, so we go in that order. Then I have some function. It doesn't have to look like that. I just randomly drew a function. But what the intermediate value theorem says, that if f of a and f of b have opposite signs, see, f of a is positive because it's above the x-axis. F of b is negative because it's below the x-axis. Then the intermediate value theorem says that since that function has to cross through both of those points, at some point in between there has to be an x-intercept or a root or a zero. So the way that we can use that, actually the graphing calculator uses it when you do that second calc for finding a zero, and then it says left bound, right bound guess. It's looking to see if one of them is positive and one is negative, and then you guess where the zero is. That's how it finds it. So it just kind of zooms in on it a little bit at a time. And that's what we're going to do using synthetic division. And I will kind of run through these computations using my calculator because the numbers are going to get a bit on the difficult to do mentally side. So what we're going to do is figure out if there is a root between 1 and 2, and if so, we'll estimate the root to the nearest 0.01 using the intermediate value theorem. So how do we know if there is a root? Is there a root between 1 and 2? If so, then f of 1 and f of 2 will have opposite signs. So let's check that first. And I'm going to do like my shortcut for synthetic division because I don't want to write out a whole bunch of synthetic division. So we'll put our coefficients. So 1, -1, 7, -7, -18, and 15. And then draw a line for my remainders. And I'll put 1 in to start with. So drop down the 1. 1 times 1 is 1, plus -1 is 0. 0 times 1 is 0, plus 7 is 7. 7 times 1 is 7, plus -7 is 0. 0 times 1 is 0, plus -18 is -18. -18 times 1 is -18, plus 15 is -3. So f of 1 is -3. Let's try f of 2. 1 drops down. 2 times 1 is 2, plus -1 is 1. 1 times 2 is 2, plus 7 is 9. 9 times 2 is 18, plus -7 is 11. 11 times 2 is 22, plus -18, 4. 4 times 2 is 8, plus 15 is 23. So f of 2 is 23. So what that tells me is by the intermediate value theorem, since f of 1 is negative and f of 2 is positive, there is a root between them, between x equals 1 and x equals 2. So then what we're supposed to be doing is picking or using the intermediate value theorem to estimate that root to the nearest 0.01. So since I know it's between 1 and 2, I'm going to pick a number between x equals 1 and x equals 2. So let's say I pick 1.5. Here's where using your calculator is going to come in handy. Because what I want to do is synthetic division. So I have to do, drop down the 1. 1 times 1.5 is 1.5 plus negative 1 would be 0.5. And then times 1.5 plus 7, 7.75. And then times 1.5 plus negative 7, 4.625. And then times 1.5 plus negative 18, negative 11.0625. Times 1.5 plus 15. Negative 1.59375. Okay, now I want to know where my root is located. So if you look at 1.5 is negative, 1 is also negative, but 2 is positive. So what this is showing me is since f of 2 is positive and f of 1.5 is negative, now I know the root is between 1.5 and 2. So I pick a number that's in between 1.5 and 2. Pick a number between x equals 1.5 and x equals 2. So let's pick, I don't know, something close. It's probably closer to 1.5 than it is to 2. So maybe I'll pick 1.6 or 1.7. I don't know. I'll just pick 1.6. See where we go. So if I pick 1.6, the 1 drops down. And then I do 1 times 1.6, which is 1.6. Add it to negative 1, I get 0.6. And then times 1.6, add it to 7, 7.96. Times 1.6, add it to negative 7, 5.736. Times 1.6, add it to negative 18, negative 8.8224. Times 1.6, add it to 15, 0.88416. Okay, now I want to look at where the sign change happens. I was picking a number between 1.5 and 2. So I'm looking at 2 and 1.5. So these two values. At 2, my function was positive. At 1.5, my function was negative. And at 1.6, it's positive. So here's where my sign change happens. So that tells me now that the root is between 1.6 and 1.5. Because I had a sign change, 1.5 was below the x-axis, 1.6 gives me a point above the x-axis. So somewhere in between 1.5 and 1.6 is where that function crosses over. So now I'm going to pick a number that is between 1.5 and 1.6. Whoa, I left out some letters. Between x equals 1.5 and x equals 1.6. So maybe right in the middle, 1.55. So if I choose 1.55, and then I do that synthetic division again. So bring the 1 straight down. 1 times 1.55 plus negative 1 gives me 0.55. And then I do times 1.55 again, plus the 7 up here, 7.8525. Times 1.55 plus negative 7, 5.17. I'm not going to write down the whole number. times 1.55 plus negative 18, negative 9.98 times 1.55 plus 15, negative 0.475. Okay, so now I see that at 1.55, the function is below the x-axis, and at 1.6, the function is above the x-axis. So here I have a sign change. So now that tells me the root is between 1.55 and 1.6. So I need to pick a number between 1.55 and 1.6. Between x equals 1.55 because the y value was negative, which means it's below the axis, and x equals 1.6 because the y value was positive, which means it's above the axis. So somewhere in between 1.55 and 1.6, that's where my function crosses. So maybe I'll pick 1.57. So I do all of that synthetic division again. So I bring the 1 straight down. And then I'm taking 1 times 1.5, 1 times 1.57 plus negative 1 from here, 0.57, times 1.57 again, plus 7, 7.8949, times 1.57 plus negative 7, 5.39, times 1.57 plus negative 18, negative 9.529, times 1.57 plus 15 is 0.038. 118. Okay. Okay, now let's see where the sign change happens. The function is above the x-axis when x is 1.57, and the function is below the x-axis when x is 1.55. So in between here and here is where it crosses, somewhere between 1.55 and 1.57. So we will try one more value, I think, then we'll get it. The root is between 1.55 and 1.57. So since we're only going to the nearest 0.01, the only possibility we have is 1.56. So we pick a number that is between x equals 1.55 and x equals 1.57. So we pick x equals 1.56, and we're going to do that synthetic division one more time. So again, we bring that 1 straight down, and then we do 1 times 1.56. We add it to the negative 1 up here. So 0.56, and then times 1.56, add it to the 7, 7.8736, times 1.56, add it to the negative 7, 5.282816, times 1.56 again, plus the negative 18, negative 9.75, times 1.56, add it to 15, negative 0.223, 7389824. Okay. So now we see that the root is going to be somewhere between 1.56 and 1.57, because here it's positive, here it's negative. So I know it's between these two. But which one is it closer to? Because we're supposed to estimate only to the nearest 0.1. So I have to decide that it is closer to either 1.56 or 1.57. At 1.56, we're at negative 0.22. At 1.57, we're at 0.03811. So it's closer to equaling 0 at 1.57. So we would say it's closer to 1.57. So we would estimate the root at approximately 1.57.